In this video, we'll talk about temperature and density. So with temperature, the three units that we might encounter, the first one is Fahrenheit. And honestly, in class, except for this chapter, we don't usually encounter Fahrenheit. This is an English unit, which I know we use for our weather and things like that. But in science, we typically use degrees Celsius. And then there's also Kelvin, which is the absolute zero scale. In the Kelvin scale, 0 Kelvin, it would be the theoretical place that's the lowest temperature that you could possibly go. Now, we don't use Kelvin a lot except when we use gas laws. So in the chapter, when we get a little bit later in the course to gas laws, we will reintroduce the absolute zero scale, which is the Kelvin scale. Now, Celsius and Kelvin have the same degree size. So if you look to convert between Celsius and Kelvin, it's over here. And what you would do is add 273. Specifically, it should be 273.15. But for our introductory class, 273 is just fine. But now Fahrenheit and Celsius have their degrees, like 1 degree Fahrenheit and 1 degree Celsius are different. So their conversions, the equation that we need to convert between the two looks a little different. So here are the equations. So the first equation would be if you knew the degrees Celsius and wanted to find Fahrenheit. The second one would be if you knew Fahrenheit and wanted to find Celsius. And then I already mentioned the third one is if you want to find Kelvin. Now notice Fahrenheit isn't related to Kelvin. If you were given Fahrenheit, you'd have to go from Fahrenheit to Celsius to Kelvin. So like we could kind of think the degrees Fahrenheit we can relate to degrees Celsius. And degrees Celsius we can relate to Kelvin, but Fahrenheit and Kelvin would have to go through Celsius to meet them. The other thing I want to point out to you is that these first two equations are actually the same equation, just mathematically rearranged. So there's not two different equations to figure for the relationship between Fahrenheit and Celsius. I've just rearranged them for you so you have two. You do not need to memorize these three equations. Let me even be more specific. You do not need to memorize any of the equations in this box. Those three equations to change between the different temperature scales will be given. You'll need to know how to plug it into your calculator, but the equations will be given. Okay, so let's take a look at density. So you can practice temperature. I think there's a homework problem that would help you practice it, but since it's just kind of a plug and chug problem, I'm not going to do that right here. So let's take a look at density. First, we'll define density, and then on the next page, I have some problems. So density is a physical property, which means if you were to think about the beginning of this chapter, a physical property is something that can be observed or measured without changing the composition of the substance. If you look at the equation, what density is, how we determine density is we can measure the mass and the volume, and density is equal to the mass divided by the volume. And we'll do a lab where we take a sample, we'll measure its mass and we'll measure its volume, and then we'll calculate what its density is. So we can measure density without changing the substance, which makes it a physical property. Now, the few things about density is that it depends on temperature. So you see here it depends on temperature. Now, why it depends on temperature is because volume changes with temperature. As we heat something up, it expands. So in general, if the volume, the denominator, is expanding, in general, density decreases as the temperature increases. So as it gets hotter, in general, density becomes lower because the particles spread out farther and farther apart. You could also say that in general, as something cools down, that substance becomes more dense because the particles get closer and closer together. Now, density, if you have two substances that will not mix, you can determine which one has the lower density because the lower density substance will float on a higher density substance. One example that you may already know is the example of oil and water. So if you think about oil and water, oil floats on water, which tells me without knowing any numbers that oil has a lower density than water. Now, water is just such an interesting substance, and so one of the things that we kind of end up knowing a lot about water, and one thing is the density of water. So the density of water to three significant figures is 1 gram per milliliter. Now remember, it changes with temperature. So this 1 gram per milliliter is around room temperature, which would be around 22 to 25 degrees Celsius. Now, what is unique about water? So that's its density. That's not particularly unique, but what is unique about water is that its solid has a lower density than its liquid. Now, if you think about it, I mentioned that density depends on temperature, and normally as you get cooler, you get a higher density. So we would expect for most substances, the solid has a higher density than the liquid. But in this case, ice, solid water, has a lower density than the liquid water. So, and you might think, well, how would I know that? Well, ice floats on water. So it's kind of peculiar, but around 4 degrees Celsius, remember ice freezes at 0, around 4 degrees Celsius, instead of contracting and the water molecules all coming together, because of their shape and their interactions, water as it freezes starts to expand. Maybe you've put a water bottle or a soda can in the freezer and it exploded. This is why. Because water, instead of contracting as it freezes, expands. And so ice floats on water. And that is something that's unique about water. Well, the other thing that's related to density, and on the next page we're going to do some calculations with density, but conceptually, the other thing that is related to density is called its specific gravity. And specific gravity is just when you compare the density of a substance to the density of a standard. Now, in this case, I wrote water here, and that's because water is the standard for both liquids and solids. If we were doing a gas, the standard for gas would be an air. But normally we're talking about liquids and solids. So specific gravity is simply comparing the density of your substance to the density of a standard, and in this case it would be comparing it to water. Now, if I know that if I say that water is 1 gram per milliliter, that would tell me that for the specific gravity would have the same number as its density, but if we have grams per milliliter as the density, and grams per milliliter on the top and on the bottom for the water, that those cancel. So specific gravity ends up having no units. So say, for example, that a saline has a density of 1.50 grams per milliliter. So that would be saline. and this is its density, then its specific gravity would simply be 1.05. So it would not have units, and since we'd be dividing by 1, because that's the density of water, or the standard, the number would stay the same. Sometimes they use, if you work in a doctor's office, they use specific gravity. They measure the specific gravity of urine, and it's something called a urinometer. And so the specific gravity of a urine sample can check if a patient has some type of metabolic problems, because densities are physical properties. They're constants for different substances. And so urine is a mixture, and it has a range that's normal. And so if it's outside that range, high or low, that can indicate that there's a problem with the patient. So sometimes in doctor's office, they'll measure specific gravity of urine. Let's try to do a couple calculations with density. So we have the conceptual part of density. So we know it's the comparison of it's the grams per the volume. It's the mass over the volume. That makes me think, I don't think I mentioned it, but I need to mention it now, that the units, so the common units, it's not always the units, but the common units for density are grams per milliliter. So conceptually, we know density is measuring comparing the mass to the volume. We know it depends on temperature. We know it's a physical property, so it can be used to identify a particular substance, or sometimes it can be used to help us understand a little bit about a mixture. We know that lighter substances, lower density substances will float on higher density substances. But another one of the things that we have to do with density outside of the conceptual things is to use it in a calculation. So here I have 3 different problems for calculation, to do a calculation. And so just remembering, I have density equals mass over volume. So that's the algebraic equation. And so there's 3 different parts to this. There's density, there's mass, and there's volume. So you can have 3 different kinds of questions. You can have where it asks you to calculate the density, where it asks you to calculate the mass, or where it asks you to calculate the volume. And I have an example of each one of these. Now there's 2 ways to solve all these problems. The first way would be simply to just plug in the numbers. The second way would be to use density as a conversion factor. And I'm going to show you the second way on questions 16 and 17, because that's when it's most helpful. So let's take a look at these and see what we can do. And if you'd like to pause the video now and see how far you can get, you can. And I'm going to go ahead and solve these. So it says if a urine sample has a mass, so the problem gives me, it says I have a mass of 122 grams. And I have a volume of 121 milliliters. And then the question is, what is the density? So this is probably the most straightforward problem. You know that density algebraically equals the mass over the volume. You were given the mass of 122 grams. The volume is 121 milliliters. And so 122 divided by 121 is, I got an error when I plugged my calculator. Okay. It equals 1.00826. The units would be grams per milliliter. Now that's what my calculator says, but I want to think about significant figures. So this number has 3 significant figures, and this number has 3 significant figures. So we always, when we're multiplying and dividing, we want to go with whatever's the least. So if both numbers have 3, then I'm going to want 3. So it'd be 1, 2, 3. But I'm going to drop off an 8. So since that's greater than a 5, I'll have to round up my last number. So it's 1.01 grams per milliliter. And that would be the density of this urine that was in the problem. Okay, so that's probably when you're calculating density, you just plug them in and divide. Then try to round to significant figures. So now let's look at question 16. And I'm actually going to show you two ways of doing this problem. Draw a line in the middle. You don't have to do both ways. I just like to show two. There's algebra, and then there's conversion factors. I like the second way better, but you choose. You practice and choose. So question 16 says, calculate the mass in grams of 10, and then this, I think I made a typing mistake. It should just be 10 milliliters. So that's the volume. I said the volume is 10 milliliters. I know it's volume because milliliters are volume of diethyl ether, an anesthetic that has a density equals 0.713 grams per milliliter. Okay, so in this problem, they gave me the volume and the density, and they're asking me to find mass. So using algebra, I would say density equals mass over volume. So I would plug in 0.713, and you don't have to write the units if you don't want to. 10.0 milliliters, and then the mass. So rearranging this, I would say 10. I have to multiply the 10 over. And so solving for this problem, and sorry I didn't give myself enough room when I typed this up, it would be 10 times 7.713. So I'm going to write it up here. Go up here. The mass would equal 7.13 grams if I solved it algebraically. And I feel good about three significant figures because if I look, 10.0 has 3 and 0.713 has 3. So my answer would be that 10 milliliters of diethyl ether would weigh 7.13 grams. Now I can also use density as a conversion factor. And so if I look at density is telling me always how many grams I have in 1 milliliter. So they told me that I have 0.713 grams, and it's written like this in the problem, but what they're telling me is that I have 0.713 grams in 1 milliliter. That's what density is, just telling us how many grams per 1 milliliter. Now, if you look at this right here, that just looks like a conversion factor, right? Anytime I can write one thing on top of the other, that's a conversion factor. Okay, so I never start the problem with a conversion factor. What else do I know? I know there's 10 milliliters. So I'd say 10 milliliters, and then I'm going to multiply it by the conversion factor. If I would want to have the milliliter on the bottom so that it would cancel. So then I would put the 1 milliliter on the bottom and the 0.713 grams on the top. The milliliters cancel, and it's 10 times the 7.713. Whoops, sorry. And I get, obviously, the same answer. But for me, just looking at this compared to that, I like doing it the method 2 better. But I'm not going to try to convince you. You can either just solve your algebra, which is fine, that's way 1, or you can practice using density as a conversion and see how you do, and that's method 2. You don't need to know both methods. Okay, this is something that you can really do on your own, like decide on your own by practicing, and what helps you get the answers get the answers right. Okay. So question 17. Let's try this one and see. And we're going to do it two ways again. That's why I drew my line. We're going to try with algebra, and we're going to do it with the conversion factor. And if you want to, you can pause it anytime and try on your own. So it says calculate the volume. Okay, so this is what I'm trying to find, the volume. So I need to find volume in milliliters of 100. And this is not supposed to be a capital. On the Word document, it must have corrected it. It loves to autocorrect lowercase letters. 100 grams of coconut oil, which has a density of 0.92 grams per milliliter. So I know the mass is 100, and notice they put a decimal there to make it 3 significant figures, and it has a density of 0.92 grams per milliliter. So if I'm using algebra, I would say density equals mass over volume. Now, I know the density is 0.92 grams per milliliter, and that's going to equal, now this time what I know is on the top and the volume's on the bottom. So this is in general a little bit trickier, because we've got to get the volume off the bottom. So I'd say volume times 0.92 grams per milliliter equals 100. And then I would divide both sides by the 0.92. And I'm not showing all the, I didn't show the dividing here because I'm running out of room. But think about your math. And this is volume equals. This is something you've done before. So in math, it's not a new thing. Divide it. You might have to dust off your memory, or I'm happy to go over it with you. And I get, when I divide those two, I get 108.6. It keeps going, 6995. It's going to be in milliliters. And so when I look back at, when I'm thinking about significant figures, this number had 3, but this number only had 2. So I'm going to ask you a question. You see if you can answer it before I do. If I have this as my answer, how do I round 108.695 milliliters to 2 significant figures? Okay, I'm going to write it down. See if you can pause it if you want to think about it before I write it. The volume, you would take it. So I only want the first 2 digits. This is an 8, so it would be 110. No decimal place, because that would make it 3 milliliters. So there's my answer. So you can see, I know I didn't leave a lot of space there, but you can kind of go through it, and you can see that was my algebra way. Now, conversion factor way, let's think about it. I still want to find volume, so I'm going to find volume in milliliters. But this time I'm going to say, okay, well, I know the density is 0.92 grams in 1 milliliter. That guy right there is written like a conversion factor, right? Anything when you have one on top and one on the bottom. And notice remember that's what density tells me. It tells me how many grams I have in 1 milliliter. It's always in 1 milliliter. So let's see. Then I write down what I was, solving conversions, I write down what I was given. So I say 100 grams times. Now this time, thinking about it, I know you're just maybe learning conversions, but if I have grams here, I know I'm going to want to have grams on the bottom. And the reason is because I want it to cancel. So I'm going to put the density, the 0.92 grams on the bottom this time. So my grams are going to cancel, and the 1 milliliter on the top. And when you do that, you'll notice it's 100 divided by 0.92. And again, I get the 108.6. It keeps going on. And to 2 significant figures, I would get 110 milliliters. So notice I get the same answer. Again, in my mind, I keep thinking, okay, my algebra, I kind of went through this whole process over here, and in the conversion factor, I just did that. So I prefer the conversion factor. If you start practicing and get an idea, I feel like it's simpler. But again, you can choose whichever way you would like to solve these problems. So anytime there's problems, I know you could feel like, I don't know what I'm doing, but please practice, ask questions, and just keep working on it. I know you can get it.